Welcome to Strata Green monthly webinar. I'm very, very excited to learn new things today, and I hope you are as well. Please let me introduce you to our very special guest speaker today. We have Narelle Brown. Hi, Narelle.
Hello.
So Narelle Brown is a chemical engineer from C&N Brown Consulting, and we are so privileged to have her speaking today. Again, let me just remind you of the topic. Today's topic is liquid smoke and its benefits. I know liquid smoke is on the trend. Everybody wants to know and learn more about it. The subtopics will be the difference between liquid smoke and wood vinegar, as well as the importance of clean smoke and its benefits. I will let Narelle introduce herself further and start with the presentation.
Morning and good afternoon, everybody. As Lara said, I'm actually located in Victoria, so it's afternoon over here, a little bit of a wet day, but we've had warm weather in the past few days, so the rain is wanted over here. Anyway, today I'll be talking about liquid smoke and its use in the horticulture agriculture scene. Liquid smoke has been around for a long, long time in the food industry, and we're actually going to be seeing how it's transferred into the horticulture industry probably in the last 30 years. So things have changed more recently. There's a lot more research that's been done in this area, and they're finding things every day about liquid smoke and its use, especially in germination of seeds. So from that, I'll pass on to my presentation. All right. Okay, so today I'll be talking about liquid smoke in particular and working towards a cleaner world. So a lot of people think liquid smoke is a fake chemical. It's actually a natural chemical, and it is produced from the smoke of timber, which is condensed onto water. So we'll go through quite a few different scenarios today. So first off, we'll discuss some of the definitions in the smoke industry. There's a lot of confusion around what is liquid smoke, what is wood vinegar, what is pyroligneous acid, what is smoke water. So there is a lot of confusion about what is what in the industry. We'll then touch a little bit about the manufacturing process of liquid smoke and what are the differences in pyroligneous acids. What affects the quality of the smoke, so in terms of the actual process. Some of the chemistry of liquid smoke. So this is natural chemistry of a natural liquid smoke. We'll then cover some of the compounds found in liquid smoke, and these particular compounds are what we're finding to actually assist in the germination of seeds and in plant growth. We'll then look at what is the difference between food grade liquid smoke versus non-food grade smokes. From that, we'll lead into clean smoke options, and a little bit about the research and development and where this has come from in the past and where we're heading to in the future. And finally, we'll just finish up with a little bit of a summary and some questions at the end. So the first thing, pyroligneous acid. Most people have heard about pyroligneous acid, or PA for short. This refers to all products of liquid smokes, wood vinegars and other smokes. So it includes, your standard wood vinegars that you find in the market. It includes all liquid smokes that are found in the food industry and in the horticulture industry. It includes all your smoke waters, all of it. So it's a general term for products that are produced from the pyrolysis of vegetable matter. So it's not just timber, it's all vegetable matter in this case. The next one is wood vinegars. Now, as the name suggests, wood vinegars are produced from timber. The timber undergoes pyrolysis, which is the process of heating timber without the oxygen being present. So minimal oxygen there, and the product is, I suppose it's like roasted instead of burnt. So we roast the timber, and the gaseous phase comes off and is collected onto water. Now, some wood vinegars in the world are actually a very clear solution and are used as medicinal purposes in Japan. So they use them for like foot pads and things like that. But it is very clear. It looks like water. but it's actually a wood vinegar that they use. It's highly refined product. Other wood vinegars that we find, especially here in Australia, are raw materials. They are generally not refined. They have high levels of acidity in them, especially of acetic acid, and that's why the name is referred to as a vinegar, because we all know vinegar is acetic acid. So wood vinegar, made from wood, high in acetic acid, but is generally not refined. It normally contains still tars and insoluble liquids in the product. The next one, which is quite common and we've heard around the industry, is smoke water. Now, smoke water is not generally produced by pyrolysis. It's normally produced by burning vegetable matter and bubbling the smoke through water. A lot of small organisations actually make smoke water for themselves, and they will actually have a little setup where they burn the timber or burn some vegetable matter, and they bubble the smoke through water to produce what is called smoke water. This can be used for germination of seeds. It's normally a weaker solution, low in concentration, but it does have its place in the market. And the final one is liquid smoke. And this is the one I'd like to talk about the most today. Liquid smoke refers to the pyrolysis of generally timber, a hardwood timber. They're selected timbers, and they've been processed further to remove tars and insoluble liquids. The key point here is the removal of polyaromatic hydrocarbons, or PAHs. Now, PAHs refer to chemicals such as benzopyrene. Now, these chemicals are believed to be carcinogenic and must be removed to be used in food applications. Liquid smoke has come from the food industry and has a control on how many of these PAHs are allowed in the product. It is made for food applications. It is used here in Australia in making of hams, bacon, frankfurts. It's added into sauces like barbecue sauces. It's added into baked beans, your ham flavoured and barbecue flavoured baked beans. It's used in quite a few different areas in the food industry. So it is safe to use, and we're going to talk a bit why we use food grade liquid smoke over using non-food grade products, because it's quite important that we keep the food chain free of these contaminants. So this is a little bit of a picture of the process which is in the production of both wood vinegars, pyroligneous acids, and liquid smoke. So normally we start off with sawdust collected from timber, and liquid smoke it is from selected hardwoods that they collect from the industry, and it's normally a sustainable industry. So it's collected from a process that is already using the timber, and the sawdust is collected from that process. It then enters a pyrolysis furnace where the timber is roasted or heated up without the presence of oxygen, and the timber basically burns without a flame. The gas from that process is then passed through a condenser or absorption column, and we get out of that a pyroligneous acid. Now, at this point, if we were to draw off the liquid from here, it would be known as wood vinegar. We also get out of the furnace, because a solid product is left after the pyrolysis process, we get out biochar. Now, I know biochar has been around the industry a little bit, and probably most people have heard of biochar. It does come from this process. So this process is quite a clean process in that there are many things gained from a raw material that has been, that would otherwise go to waste. Now, from the condenser, to make the difference between wood vinegar and liquid smoke, it undergoes further refinement. So it undergoes separation, distillation, and filtration. Now, that is to remove the PAHs, or the polyaromatic hydrocarbons, the carcinogenic products, and we end up with a liquid smoke, which is for food production. So this is where the difference is between wood vinegar and liquid smokes. Okay, so we've got a couple of different products here. In the first slide on the left-hand side, on the left we have a pyroligneous acid or wood vinegar. On the right, we have a product called Fire Stick, which is a liquid smoke. Now, under both of those beakers is a light shining up from a mobile phone. Equal intensity light coming up from both phones. But as you can see, the sample on the left does not let light through. And that is mainly due to sediment in the product, which is refracting and reflecting light. The sample on the right, as you can see, is quite clear. And that is because the sediment and the tars and insoluble liquids have been removed from this product. Now you can see on the right-hand picture that the smoke, that the pyroligneous acid or wood vinegar has been slightly filtered, and you can see that sediment settled on that filter paper, while you compare it to the sample of Fire Stick on the right, which is quite clean. And this is what makes the difference between wood vinegars and liquid smokes, is what is actually left in the product in terms of sediment and contaminants and also PAHs. So what affects the chemistry of pyroligneous acids? So the big questions are, has the product undergone pyrolysis or flaming combustion? So what I mean here is pyrolysis is where we roast the timber with the absence of oxygen, and flaming combustion is where we actually have oxygen present and a flame is also present on the timber. So under pyrolysis, there is no flame. It is just the roasting of the timber and the gaseous smoke coming off from the timber and being passed through that condenser. Flaming combustion is totally different, and as a result, you will get different chemicals being produced when the flame is present. What temperature is the pyrolysis process happening at? This will also affect what chemicals are produced in the pyrolysis process. This is strictly controlled in the food applications, such as in liquid smoke, because the products you want have got to be suitable for the food industry. And we'll talk a little bit about that in the next slide. So how long has pyrolysis occurred? So are we talking about fast pyrolysis or are we talking about slow pyrolysis? Once again, this affects what type of chemicals are produced in the actual pyrolysis process. The moisture content of the product undergoing pyrolysis. So with the liquid smoke, the food grade liquid smoke, this is controlled strictly to ensure the timber is at the correct moisture content to ensure the right chemicals are produced during the pyrolysis process. The particle size also affects what chemicals are produced during pyrolysis. As you can imagine, smaller particles have a greater surface area and allow heat to penetrate into the timber a lot easier compared to the larger chunks of timber. The temperature of the product has been cooled to. So when the gas enters into the condenser, what is the temperature at the top of the condenser? If it is higher, it's going to allow chemicals that have a higher dew point to be passed through. So, it's got to be at a temperature that allows for things like acetic acid to be condensed. If not, you're not going to capture the right amount of acetic acid or other chemicals that you require in the liquid smoke. Okay, what concentration is the pyroligneous acid? So, as I mentioned before, you've got things like smoke water, which are very weak products. But pyroligneous acid can vary in strength depending on how the process is managed. Liquid smoke for the food industry is actually quite a concentrate product, mainly for commercial reasons. But this can be altered to be changed depending on what your application is. So in horticulture, you can actually reduce the concentration down to the level that you require for if you're doing seed germination or something like that. So it can be altered, it can have water added back into it and quite safely used. And most importantly, what material has undergone pyrolysis? So I've got a picture there. There are different products that people use to make wood vinegars. So some people use different types of vegetable matter, such as straw. Some people use prunings, such as branches, and they may be, green timber or dried timber. And of course, there's timber. And whether we're using softwood timber or hardwood timber, that makes a big difference. All these different vegetable matters will produce different chemicals in the final product. As I mentioned, liquid smoke for the food industry uses selected hardwood timbers. It is very strictly controlled what is used in the production of food grade products. Just a little bit on timbers. So what we've got there in the middle is a picture of a timber fibre. Typical fibres in timber, they look like straws. So if you can imagine all straws and they're all stuck together, you've got holes down the centre, which is called the lumen, and then the wall of the straw is made up of multiple different layers. And those layers have different quantities of cellulose, hemicellulose, and lignin. I like to refer to lignin as the glue in timber. It glues these straws together. So when you have a chemical reaction, such as in a pyrolysis furnace, the products produced from that furnace will be the result of the reactions of cellulose, hemicellulose, and lignin to the actual flame. Softwoods and hardwoods will produce different types of chemicals because there's different quantities of cellulose, hemicellulose, and lignin between hardwoods and softwoods. So yeah, it's quite important that we use the correct timbers, especially when making food grade products, that a hardwood is used and not a softwood product. The other thing that I've already mentioned is critical is the moisture content, the temperature of pyrolysis, and the particle size. So things to consider with clean liquid smoke is ensuring the least amount of contaminants and unwanted polyaromatic hydrocarbons are formed in order to meet food standards. Okay, natural chemistry, natural liquid smokes. So this is a slide probably more food orientated, but you can see where liquid smoke in the food industry has come from and is moving into the horticultural area. So we have phenols, and the phenols in liquid smoke for the food industry is the flavours. So if you use too much liquid smoke, for those people out there who are smokers, keen smokers in their barbecues and things like that, if they get a bitter taste, you've used too much smoke. Okay, that is the phenols. So if you've used too much liquid smoke, the phenols are too high and you end up with a bitter flavour. Second product, or chemical group, which is important, is the carbonyls. And this gives us the colour. And colour is important in food smoking because it gives that nice brown colour on the outside. The acids and aldehydes are the antimicrobial. So if we think back to the caveman days, why did we smoke product? It wasn't just for taste or colour, it was mainly there to preserve the product. They would smoke meats and things like that just to keep the meat for a longer period of time. So in the old days, the antimicrobial side was very critical in maintaining and preserving the meat products or food products. These days, it's still important, but not as important as the flavour and colour. People are looking for that nice smoky flavour and they're looking for that nice brown colour on the outside. Some of the other chemicals that are in liquid smoke are esters, furans, and ketones. So you can have a look on that slide yourself. Down the bottom is mainly talking about what is related to the food industry. We're going to be looking at where it's used in the horticulture, agriculture industry, and what types of chemical compounds are important for those applications. So some of the natural compounds found in liquid smoke extracts. So the first group is polyphenols, and it's quite a large group of polyphenols in liquid smoke. It is a naturally occurring organic compound. It is found in a lot of vegetable matter and plant foods, and is actually beneficial for human health. So it's in foods such as fruits, vegetables, herbs, tea, red wine, and dark chocolate. So polyphenols act as an antioxidant in the body, which means they help to neutralize free radicals that cause cell damage in the body. So they are actually found naturally in a lot of products, and they are also found a lot in liquid smoke products. So some of the groups like flavonoids, which are around 60% of the polyphenol group in liquid smoke. These flavonoids are products you may not even realise, but are in things like red wine. And the tannins that you get in red wine are actually made up mostly of flavonoids. And that's where you get that bitter taste sometimes with the tannins, is from a phenol product. So there are quite a range, like phenolic acids, they're around 30% of polyphenols, and they're found in things like fruits, vegetables, whole grains, and seeds. Polyphenolic amides are found in chili peppers and oats. And the final group, which is all the other polyphenols, are mainly found in berries, some in red wine, turmeric, flax, sesame, and whole grains. So we find it in quite a few areas. But this is a critical group, polyphenols. Then we start to break down into what is more critical for seed germination. And we get the group of butanolides. Now, butanolides have been derived down further into carrageenans. And I'll talk about carrageenans next. But what was initially found was the group of butanolides was responsible or found to trigger seed germination in plants whose reproduction is fire dependent. It's not all plants. It's only some plants, and I think they found around about 400 native species responded to smoke in their initial work. And I'll talk about the research work that was done early on in the 1995s. The second group is carrageenans. Now, carrageenans are a subgroup of butanolides. Excuse me. They are found to be plant growth regulators from smoke burning from like fires, and also from things like liquid smokes. So carrageenans help stimulate seed germination and plant development because they mimic a signalling hormone known as spironolactone. Now, spironolactone is a symbiotic fungi in the soil, and it helps plants grow and increase in plant branching. So what we normally see in a normal fire, or bushfire or a wildfire, the fire happens, smoke is produced in that fire. Smoke doesn't just waft away, it is actually settled in the soil. And when we get rain, the rain comes and pushes the smoke down into the soil levels, down to the seeds, and germinates seeds, or triggers the germination of the seeds. Those seeds then begin to grow because they've got the moisture from the rain, and we end up with new growth after the fire. And that's typically what we normally see after a wildfire's gone through. After the first rains, we start to see nice green shoots starting to come up where the fire has been. So carrageenans were actually discovered by a group of researchers in Western Australia. Kingley Dixon was one of the key researchers in this area. And carrageenans is a name that has been derived from the word carrig, which is an Indigenous Australian word, meaning smoke in the an Indigenous Australian language over in Western Australia. That word has then been used to define this group of carrageenans that have been found to assist in the germination of seeds. So you can see the 4 carrageenans there on the slide. They're not the only chemicals that assist in seed germination. What we do need to remember that there is over 3,000 chemicals in smoke. And I'm sure that there are a lot more chemicals in smoke that actually assist with plant growth and seed germination than what has already been discovered. So one more group that assists with seed germination is cyanohydrins. Now, cyanohydrins, they act similar to carrageenans in that they signal for seed germination, especially in the upper layers of soil where dormant seeds reside. Now, what they have found is certain native species, for example, kangaroo paw, is not, the seeds are not germinated or triggered germination by carrageenans, but they're actually triggered by cyanohydrins. So this is where different species of plants are triggered by different chemicals in the smoke. So once again, cyanohydrins are produced from the burning of vegetable matter. So it's a new area that's been explored. And as I said, there's going to be further chemicals I'm sure they're going to find in the future that'll assist in the seed germination and growth of plants. So the big question is, why do we use a food-grade liquid smoke over a non-food-grade liquid smoke? A food-grade liquid smoke, as I've already mentioned, is produced from selected hardwoods that are dried and milled to a certain size before being pyrolyzed in a reactor. The gas is condensed in an absorption tower, and then it is further refined to remove polyaromatic hydrocarbons such as benzopyrenes. Now, the other thing is that the hardwoods that are selected don't have contaminants in them. So if you were to use something like treated pine, we've got other chemicals that have been added to treated pine that could actually contaminate the food chain, if you like to think of it. When we add these products into the soil, the carcinogenic material, if it's a food product that has low carcinogenic material, you haven't got those carcinogens going into the environment. When you're using a non-food grade product, carcinogens and contaminants can be passed into the environment and into the food chain. So one of the main reasons we promote the use of food grade products is because they haven't got those contaminants and hasn't got those carcinogens in it and will not be affecting the food chain. The important thing to remember though is some liquid smokes have been over-refined and they have actually removed the polyphenols that are required in horticulture and agriculture applications. So you've got to be careful which product you select. As I said, there's a lot of products on the market at the moment, and you've got to select the right one that is going to suit your applications. If you choose something that has been over-refined, it will not have the polyphenols, the carrageenans, the butanolides, and the cyanohydrins in it. So you've got to be very careful what you select. Okay, so I've mentioned here Grayston Australia, mainly because that's where my background has come from. So I worked at Grayston Australia for 20 years as a general manager. They use, their smoke is a liquid smoke that has come from the food industry. So the food smoke that they're using was developed for the use of food and is used in the food industry here in Australia. The products they are developing for the horticulture and agriculture industry have come from those smokes. So they don't have the PAHs in them, or very minimal PAHs. They don't have the contaminants in them. So it's quite a clean smoke. It is a natural smoke, and it is natural for the environment. So I've got to mention there, it actually complies with Food Standards Australia and New Zealand's standards for liquid smokes for food applications. It is a consistent product and quality because it is made in the same process with the same raw materials day in and day out. Okay, and it offers a natural alternative to other chemicals. So a little bit about research and development. We've got to recognise that in 1995, there was some work done in South Africa on the use of smoke and for triggering germination in plants over in South Africa. So they were the initial people who did the work on smoke on plants. Then a gentleman by the name of Kingsley Dixon and fellow researchers at Kings Park Botanical Gardens in Western Australia did further research on smoke germination of Australian plants. As part of that research, they concluded the compound butanolides in liquid smoke could not only successfully germinate over 400 native species of seed, but also promote early germination and healthier, more uniform seedlings of other species. In this research with Kingsley Dixon, Western Australia proudly supplied the food-grade liquid smoke as samples to be used in those trials. And that product today is commonly known as Regen 2000 SMOKEMASTER. So SMOKEMASTER has been around for since 2000, if not just before it. So it's been around for a long time. Further research and development are occurring in Australia by numerous researchers, and they are trying to understand the effects of smoke on the germination of seeds. So you'll see here in the little picture I've got down the bottom, this was the initial work that was done where they had the dormant seed, correct temperature, correct moisture, dormancy is released, and you've got butanolides from the smoke coming in with light and other chemicals. And as a result, you get the germination of the seed. So this has been further refined by Kingsley Dixon to talk about carricins, and now we're talking about cyanohydrins as well. So some of the other further research and development of Regen 2000, there are a number of people who have done research with the product with positive results. We have also done a lot of work, not just here in Australia, but also internationally. Western Australia had a policy for quite a few years of sending samples around the world to different researchers to try on different products. And it has been used in numerous countries for those trials. And, you know, as a result, we get some good results coming back. And as with all research, you always sometimes get results that you don't expect. But we've done a lot of work here in Australia as well as the international work. This is with the Regen 2000 product range. So in summary, many products are sold in the market claiming they can benefit horticulture and agriculture applications. As I've mentioned, you've got to determine which one is correct. Okay, as I said, it's very confusing because you'll be told, oh, this is a pyroligneous acid, this one's a wood vinegar, this is a liquid smoke, this is smoke water. What do you make of it? Because there's so many different types of things, but they are all different. And you've got to make sure you choose the right one. And in my opinion, liquid smoke being a food grade product is perfect for horticulture and agriculture. You need to ask yourself, what type of products are these and how were they produced? Now, we've covered a lot about the pyrolysis process and that the different chemicals can be formed in the pyrolysis process. So you've got to get the right one that has produced the right chemicals. Necessary chemicals in smoke to stimulate the germination of seeds include polyphenols, butanolides, carricins, and cyanohydrins. And as I've mentioned, there are likely to be additional chemicals yet to be discovered. As I said, there's over 3,000 chemicals, compounds in smoke. So I'm sure there's others in there that are benefiting the germination of seeds, but also the growth of plants. And of course, the final point I'd like to make is the importance of food-grade liquid smokes versus non-food grade products, reducing the PAHs and other contaminants entering into the food chain. So this is the big difference between wood vinegars and food-grade liquid smokes. Food-grade liquid smokes have had the PAHs reduced and don't have any contaminants in the product because it's suitable for food. So on that note, open up for any questions.
we have a question came in from Wayne. Are there any particular timber species that are commonly used to produce liquid smoke? Are there any varying benefits offered by different timber species?
Okay, that's a good question from Wayne. The different smokes that are used in food grade liquid smokes at the moment are normally products like hickory. You've also got your selected hardwoods normally from America and used for this product in food grade. Trials have been conducted here in Australia. Grace Australia has made liquid smoke from eucalypt, and the product does appear to be okay for use in food grade. So I would say it would also benefit the native species as well.
Yep, we hope that answered your question, Wayne. If you still have further question, feel free to submit it to us. While waiting for everyone else to send through their question, that we will be answering it live. I think it's also a good timing for me to mention furthermore about Regen SMOKEMASTER. Strata Green actually have the product as well online ready. If you have any interest in purchasing them as well, you can go to stratagreen.com.au. The Regen 2000 SMOKEMASTER is a water soluble liquid smoke extract containing many beneficial smoke compounds, as per discussion earlier and presentation from Narelle, and it's proven to trigger germination and early plant development in native and non-native varieties. So we are still waiting for more questions to come in. There is one just came through from Nigel. We don't use much liquid smoke each year, so our drum of Regen 2000 is maybe a little bit old. Does it have any expiration date?
Eventually it will expire, but liquid smoke for use in horticulture in particular can last for quite a few years. So if it's, look, I would say if it's within 5-7 years, it would probably still be fine to use in horticulture.
Thank you, Nigel, for your question. Catherine just sent through a question. So my understanding is that Regen 2000 is food grade. Is that correct? Would you be able to confirm?
Yes, that is correct. Regen 2000 is a food grade liquid smoke.
How often do you need to use liquid smoke on seeds? This one comes from Brian. Brian asks, how often do you need to use liquid smoke on seeds?
Okay, you should only have to use it once. There are different types of applications you can use onto seeds. So there is the liquid product, which can be applied, like you can soak the seeds in the liquid product until the tester starts to swell. Then you dry the seeds and then sow them. Or you can actually use a dry product, which is normally used with a vermiculite base, and you can put them on the top of seed trays. When you water, the liquid smoke is released from the vermiculite and goes down to the seed and triggers the germination of the seed. Each seed is different, what is actually needed. So some of the seeds will need further applications such as scouring, maybe need heat as well as the liquid smoke. So it's not just one size fits all. You've actually got to find out what is the best fit for your type of seed.
Thank you, Brian, for the question. The next one will be from Julian. Are there specific blends for Australian native revegetation, or is it just generic blend?
The work that has been done by Kingsley Dixon over in Kings Park has been mainly on native seeds. However, we have found in our own work that it will trigger germination in things like tomatoes, basil. It'll work on agricultural products as well. They're finding that there's benefits in those areas as well. So in food type plants, they're actually finding benefits.
Julian, have a second question for you, Narelle. Are these products suitable for hydraulic application of seed, or should the seed be soaked in the liquid?
If you're talking about application onto like after restructuring after roads, and you're spreading the mixture onto the surface, you can be added into that and then sprayed onto the surface.
We hope that's helpful, Julianne. Thank you very much. Catherine has also a question here. Has there been any research to see if there is a beneficial response from soil and seed microbes in the rhizosphere? Has there been any research to see if there is a beneficial response from soil and seed microbes in the rhizosphere?
There's been work done on that. There's a symbiotic relationship with a particular fungi in the soil, which assists with plant growth. I'm not quite sure if that answers her question, but that's about the extent I actually understand of what they've done in that area.
Thank you, Narelle. Wayne's question, is liquid smoke only used for seed germination, or can it be applied after native revenge planting has been installed to help juvenile plants establish?
Not quite sure there. Is it Julian or Julian?
Wayne.
Wayne, sorry, Wayne. Yeah, I'm not 100% sure. We do know that smoke does assist with growth of plants as well as the germination of plants. As I said, it'll depend on the species of plant that you're talking about and how it actually reacts with that liquid smoke application.
Thank you, Narelle. So for all the questions that are being sent through, if you have further question after hearing answers from Narelle, feel free to send it through after the webinar as well to info@stratagreen.com.au. I know that webinar usually a short slot, and there are so many questions just coming through the chat right now. So feel free to send it through later on after the webinar. There is another question from Brian. Are there any benefits of putting liquid smoke onto established native plant? So already established native plants.
This is similar to the question that Wayne just asked. It depends on what species of plant you're actually talking about. Look, we've found that it does assist in crop plants. So if you talk about things like canola and things like that, we have seen actual benefits in that area. As a result, I would probably expect there would be benefits in actually applying to plants as well. But once again, it is species specific, and finding the right concentration to actually apply to the plant is essential.
Yeah. Also here in Strata Green, we do get emails, people asking questions that is very specific to their project. So don't feel, don't hesitate to send us email describing what type of plants and what kind of projects that you need help with using liquid smoke. We will be able to chat with you and reply to your email, and one of our consultants as well will be able to be in contact with Grace and team and helping you to find the best solution for your project. And I am still waiting for more questions. If you have, you are more than welcome to send it through right now to be answered live. But again, you can always email us after. Narelle, this is amazing. I love seeing the feedback and just hearing your presentation. It literally introduced me to just new knowledge this morning. Yeah, and it's already 11:51 right now, maybe close to lunchtime, but I will give 3 more minutes maybe for people to send through their question. Brian just would like to give a shout out to Narelle. Thank you very much, Narelle. Excellent presentation. So there you go, Narelle. Well, I reckon this is a very effective and amazing 1 hour. I'm personally blown away. I have so many questions too, but we have time limit. But don't worry, you can always send through us email, as well as Narelle. I just want to say thank you very much once again for being our guest speaker this morning. Thank you so much for all attendees for being here, for all your questions. And Narelle, do you have anything else to add before I close?
I would just like to thank all the attendees for coming along today to listen to me speak about liquid smoke and its benefits in the horticulture industry.
This is amazing. Thanks, Narelle. We should do it again. I'm just gonna put you on the spot. Thank you very much. Well, everyone, thank you once again, and have a great rest of the day. And I will be in touch with the recording. If you have registered, don't worry, you will get the link, and I will send through an email and be in touch as well. Just to close, Regen 2000 SMOKEMASTER and treated vermiculite available on stratagreen.com.au. And any additional questions, you can also send it through to info@stratagreen.com.au. We will be able to chat with Grayson Australia team as well as Narelle to get your questions answered. Thank you, Narelle. This is Lara Potter from Stratagreen. We thank you once again for your time and have a good day.
Thank you.
Yeah, Narelle.
See ya.
Thank you.